Hello, grade 8 to 12 geometry. I am back again with another video. Please, if you enjoy and you keep coming back to the channel, please consider subscribing. So we're going to be doing a bit of theory just to make sure that you guys understand whatever you taught into class. So without wasting any more of your time, let's get into the video. So we have corresponding angles, alternating angles, and co-interior angles. So corresponding angles, these two angles are equal. This is parallel to this line. And for they form an F, and for alternating angles, we see Z. And for co-interior angles, when you add these angles together, they're equals to 180. Now we have an activity here where we have this two. This indicates that these lines are parallel. So we have A here, B, C, and D, E, F, G, and H. So what we are asked to do here is to name first corresponding angles. So firstly, we're gonna start the ones that make an F. So when you are looking at this is parallel, this is parallel. So from here going this way and this way, we have an F. Try to draw this on your book and then follow my hands like this. We'll see that this forms an F. So if this forms an F, E and A are corresponding angles. E and A are the first ones. So E and A are the first corresponding angles. And when you come this side as well, you make that very same one like that. You see that F and B are also corresponding angles. F and B. And again, when you check now, when you are doing this going down, you're going to see that you draw and you're going to see that D and H as well are corresponding. D and H are also corresponding angles. And then you're going to see that C and G are also corresponding. Now also corresponding angles. Yes, corresponding make an F. So let's go again to do alternating angles, which will make a Z. So we go from here, we go down here, and we go here. So we find that D and F are alternating angles. D and F are alternating angles. And this side as well, you go here. C and E are also alternating angles. C and E make alternating angles. Even when you go this side, you have F and D also making alternating angles. And then when you go, you have C and E also making alternating angles. Now let's look for co-interior angles. So for co-interior angles, we have C and F. The angles between parallel lines have to be co-interior. They have to add up to 180. So C and F are co-interior angles, and again D and F. D and E, sorry, not F, are co-interior angles. And another thing we can also talk about here is vertically opposite angles. So when you're looking for vertical opposite angles, is this ones. B and D are vertical opposite. A and C are also vertical opposite. And E and G are vertically opposite. H and F. So co-interior angles, when you add these two angles that are co-interior, they both have to add up to 180. But when we talk about corresponding angles, which one from F, they are equal, exactly the same. If it's 80 here at D, it's 80 for G, for H, sorry. And for alternating angles as well, if it's 20 for D, it's 20 for F as well. And for vertical opposite angles, if it's 40 for A, it's 40 for C as well, right? So that is how you deal with them. And let's say, for instance, that you are given, let's say they say D equals to 2x and B equals to 4, for instance, there, and you are told to solve for x. Because they are equal, you will say 2x equals to 4. Why? Because A and B are equal. They are vertically opposite, with reason being vertically opposite. So you solve for x. X, you divide by 2, you divide by 2. This 2 will cancel this one. Then x will be equals to 2. So the value of this x is 2. And this, how much is the value of this x? Is 2. So 2 times 2 is 4. So when you find that value of x, you find out that these angles are indeed the same when you substitute 2 into the value of x. So that's how you do it. If you were given co-interior angles or any vertical opposite or what, when you are given corresponding, alternating, and vertical opposite, this is how you do it, right? But with corresponding angles, let's say C is 70 degrees, and then you are told find the value of angle F. What you do is say 70 degrees plus F equals to 108. And your reason is co-interior angles. And then you say F equals to 180 minus 70 degrees. The 70 comes this side. So when you say 180 minus 70 degrees, that's where you will find that F will be equals to 110 degrees, which will be this one. Now, whenever you are given anything and you are told there are parallel lines, and there is another one that is intersecting like this, guys, you can find either corresponding, alternating, co-interior angles, vertical opposite angles. You can find those, all those angles there. So when you are given in 2D geometry, you are given a square, a rhombus, or whatever, and you are told that there are parallel lines and there is another one intersecting like this, guys, there is no way you are not going to find corresponding, alternating, co-interior angles there. So try to find that. You will find them. So to prove that lines are parallel like this ones, parallel lines are lines that will never meet. it's a pair of corresponding angles should be equal. So we should have corresponding angles which are equal. A pair of alternating angles must be equal. Right? Only one thing has to be proven. We have to have corresponding angles to show that these lines are parallel. We have to have alternating angles or incointerior angles. Either one of these three things should apply to show that these lines are parallel. So if you don't get cointerior angles, you don't get alternating angles, and you don't get corresponding angles, those lines cannot be parallel. One of these things have to be met. So let's go to quadrilaterals. Here we have a square. So this is the square. When you have a square, all these corners make 90 degrees. So everything combined equals to 360. So a sum of a quadrilateral is 360. So we have 90, 90, 90, 90. And then, which means all the angles of a square are equal. All angles of a square are equal. So know that always you're given a square and you're asked to find this one. Remember. And then these are the sides. And all sides of a square are equal. Right? And the area is equals to breadth times, or by length times breadth. If it's 3 this side, it's 3. This is the breadth, this is the length. So the area will be 3 times 3. And 3 times 3 will give us 9. Remember. So all sides are also equals. And then we can have a line going this side and a line going this side. These lines are called diagonals. So in a square, diagonals bisect. If we say diagonals bisect, is that they cut each other into half. So let's say this is A, this is B, C, and this is D. And here we have O or M. AO equals to OC, or OB equals to OD. So this line here and this line here are equal. So meaning we can also have this angle here and this angle here equal. So they make something that we call an isosceles triangle. So which meaning this side is equal to this side, right? That is what is happening in a square. So the diagonals bisect, cutting everything exactly into half. So this and this are the same. And when angles inside a triangle are equal, we say opposite angles of a triangle, right? So opposite angle of an isosceles triangle are equal. So that's what it's meant here with those diagonals bisect. And these diagonals also cut these angles. Also, they cut the angles in half. So if you are given here as 60 degrees, so you'll say 90 degrees minus 60, you will get this other angle. Maybe this one is angle A. And then you'll find out that this one is 30 degrees when you say 90 minus the 60. We have a rectangle here. So with a rectangle, two sides are equal. So this side is equal to 2 and this side is equal. So with a rectangle, opposite sides are equal, right? So this side and this side are equal, this side and this side are equal. And again, these angles all make 90 degrees like in a square. So all angles make 90 degrees. These lines, they will never meet, so they are also parallel. So which means this opposite side, these opposite angles also do in co-interior. And then something else that we have is this one. Diagonals bisect as well. Yes, diagonals bisect. That's what you have to do. So this sides are equals to 90, and you do it just the way that I've shown you with a square. Okay, now we have a parallelogram. This one that I can't draw it perfectly, but I hope you guys do. So we have a line coming that's straight. That is the height of the parallelogram, and this side, it's the breadth. So the area of a parallelogram is its breadth times perpendicular height. This height is perpendicular because it comes here, and so that makes it 90 here. So it's a perpendicular height. It's not the height here because it's skewed, it's not straight, so we use this one, the perpendicular height. So opposite sides are equal in length of a parallelogram. And with a parallelogram as well, diagonals bisect, right? So this side is equals to this side like that. So we also have diagonals. Remember, those are the lines that cut, so they also bisect one another. And another thing, they cut each other into half. So another thing is that opposite angles are equal. So opposite angles are equal, or you can have opposite. These ones are vertically, so we just have this one are opposite. Yeah, so here we have a rhombus. With the rhombus, all sides are equal in length, and opposite angles are also equal, like a parallelogram. And something as well is that diagonals bisect perpendicular. So we have that there. It forms a 90 here, 90 here, 90 here, 90 here. So diagonals do not bisect. Diagonals, they bisect perpendicularly. They bisect perpendicularly and also bisect the angles. That is the rule. And here is what we call a kite, right? So vertical angles are equal, meaning this side and this side are equal, right? And then we have a diagonal here, and a diagonal going this side. So also these diagonals form a 90 degrees here, sorry, 90 degrees there, 90 degrees here, and 90 degrees here. So this long diagonal and this short diagonals, when they meet, they form 90. So their diagonals also bisect perpendicularly. And B, let's say this is K. So BK and KC are equal, and then AC and AB are also equal, right? These lines, and also BD and CD are also equal as well. So those are the properties of this kite. So remember, when you answer, when you are given K here and you're asked the value of K1, it's 90, K2, K3, K4. So that is how you take care of the kite questions that you have. And this AD line cuts this whole thing into graph. So the area will be AB times BC. So AD times BC is the area, the length times this length, it's the area. Thank you very much for watching. If you enjoyed this video, don't forget to like, comment, and subscribe to the channel for more content, academic content. Until the next one, bye guys.